Well, hello and welcome to another DevNation Live. I'm excited today to have Galder with us. He's going to deep dive us into big data. I'm hoping you guys are excited about big data. And of course, big data is one of those overloaded terms that has a lot of different technologies and techniques and ideas behind it. But Galder's got a really awesome presentation and a series of really awesome demonstrations I think you're going to really enjoy. And again, for DevNation Live, we run this in very short intervals, about 25 minutes of presentation and demonstration, then a few minutes at the end for questions. Please hit us on the chat with your questions. Just type those right in, and then when we get towards the end, I'll be asking Galder those same questions. So at this point, let's turn it over to Galder. Are you ready to go?
Yeah, I'm here. Hello.
Awesome.
Hello, welcome everyone. Thank you for attending this presentation on Big Data in Action with Infinispan. So today we're going to start a little bit looking at the problems of real-time big data, the data growth that are happening at the moment, and see how we can solve those with Infinispan, which is a memory data grid. And then I'll be going through a couple of live coding demos that use Infinispan, Vertex, and OpenShift. So my objective today is to show you how you can build infrastructure based on Infinispan to store, search, process near real-time big data, and how to calculate analytics as well. Now, dealing with real-time streaming big data is quite a unique challenge. This offline processing of big data has been happening for a long time, whether it's via batching or similar technologies, but you can never really get it to be fully real-time. And the reason why this is important is because even a few delay of a few seconds can mean the difference between either keeping or losing a customer, or for a financial institution, it could be the difference between increased liquidity or big losses. So real-time processing can be really crucial for certain businesses. We're also seeing like a huge data growth happening, and this is as a result of a lot of the smartphones, IoT devices. So with all this big data that is happening, how can we handle it with how can we make some sense out of it? And for these two problems, we think that memory data grids are a perfect solution for this type of problems. So what are memory data grids? Memory data grids are essentially a way to manage distributed data in memory. So what we have here is servers connected in a mesh with peer-to-peer communication style. So there's no master-slave categories. So there's no kind of single bottleneck or single point of failure. And this kind of data grids are designed to run on commodity hardware. So you don't need expensive hardware. These data grids are linearly scalable. For that, what we use a smart data distribution technique. So even if you have like a big cluster, then we can divide the data such that only certain copies of the data are maintained. So what this gives you that each node maintains a subset of the data. So by doing that, you get this kind of nice implicit data parallelism, which is going to be very important for us later on in this talk. Data grids are also elastic and handle failures transparently, so they're very, very well suited for cloud or platform as a service environments. And they can be backed by a database, file system, or other persistent stores. So if you want to give them more life to your data. And they're accessible from any type of application. So this gives you the ability to have this kind of transparent sharing of application data. And we have connectors available for Java, Node.js, C, C++, .NET, etc. Infinispan can be used in many, many different ways. I'm not going to go through all of them here because we don't have the time. So you can, for example, use it as a distributed cache or as a kind of distributed NoSQL database with querying, transactions, etc. But for this presentation, the two very interesting use cases are the one about how can we do data analytics using either distributed Java streams or with Spark Hadoop integrations, Or how can we do event-driven computations that allows us to do real-time processing of data? And the talk today is going to be focusing on these two last use cases. So the first use case, the one about event-driven computation, it's a very important for us. There are many ways in which, well, there's several ways in which you can access Infinispan, whether you go like a dictionary key value store or the querying API. But if you want to do like real-time processing, we need a little bit more advanced. This is what continuous query API gives us. It enables you to be reactive to data changes. So what it does is it's basically, the query API is an extension allowing an application to receive entries that currently match a query, and then be continuously notified of any changes that happen to the query dataset. So what this gives you is, it gives your application the ability to receive a steady stream of events instead of you having to all the time execute a query to see if there is any new data or if there is any data that is not part of the query. So this leads you to a more efficient use of the resources. So the best way to understand how it works is to really see it in action. So for that, I'm going to be showing you a demo today, which is based around the Swiss rail transport system. Here, what you see in the screen is a domain of the objects we're going to be using. So we've got a train, which obviously is a physical train, and then it represents its ID, type, etc. Then we got the station, so we've got information about the position geographically. And then for each station, we got a station board. So this is like at this moment, a particular moment in time, which trains are coming, at which platforms, etc., and where are they going. And each of the entries in the station board, we call that a stop. The demo that I'm going to show today runs on top of OpenShift. We've done several presentations already in DevNation. OpenShift is Red Hat's platform as a service that allows developers to quickly develop, host, and scale applications in the cloud environment. And this is going to be, all the applications going to be running on top of that. And the demo also uses Vertex, which is a toolkit for building reactive applications on top of the JVM. It's event-driven and non-blocking, so it means that your application can handle a lot of concurrency using a very small number of threads. So the first demo that I'm going to show you, what we're going to try to achieve is we're going to try to create, represent our data grid storing the state of the station boards at a particular time. And then what we're going to try to do is create this kind of a dashboard that shows us all the trains that are delayed in the system. So of all the trains that are going through the country, which ones are delayed? And then that way, say I'm someone in the management of Swiss transport system, I can see which trains are getting delayed, etc. So what we are going to have, that's going to be on my laptop or like kind of on my system. That's going to be on the front end, on the right-hand side. And that's basically going to be communicating with a real-time component, which is already inside the OpenShift. And then we're going to have like an injector vertical. Vertical is this kind of concept in OpenShift that allows you to, it's like an actor, or like a unit of processing. And then we're going to be feeding our data grid with data about the station boards. And then we're going to have on the left a data grid, which is 3 nodes. We distribute the data around. And then what we're going to do is we're going to work on the continuous query vertical, which is the one that allows us to say, OK, of all the station board data, give me the information about those trains that are delayed. So so now I'm going to show you all of this in action. So I'm just going to switch to my screen, to my IDE. And then what I have here for the dashboard is a JavaFX application. So I'm just going to run it as is at the moment, so that you get so you can see what it looks like. Okay, can you see? Right now it's just a little dashboard. It's empty. The code is not complete, which is what I'm going to be doing right now. So from a continuous query perspective, there's 2 things we need to do. One is define the query, and then define the listener. Here, the most thing from a structure perspective, we've got a cache, which is kind of where our base storage. And then what we're doing is for each station, we've got the station board, the current state. So what we want to do from our query is say, we want to do, from our query factory, we want to do a station board query, where we're going to say, of each station board, get me those station boards where there is at least one entry that has got more than one stop that is delayed. So the entries that is here comes from, if you look at station board, it's got a list of stops, which are main entries. So that's where this particular code is coming from. Okay, so we have our query. Now, the next part is the listener. Here, what we need to say is when we get a station board that contains at least one entry that is delayed, we get the entries, and we kind of need to pass them over to the front end. So what we first need to do is we're going to take out of each station board, we got multiple stops. So we say those stops whose delay is bigger than 0, so it's delayed. And then for each of those, we're going to be basically pushing it to the event bus. The event bus is the part that underneath is going to be making sure that this is shipped over WebSocket to our front end. So we've got the query now, we've got the listener in place. The final thing we need to do is put the two together. So what we need to do is here is say, okay, continuous query, add for this query, add this listener. That's it. Now the next step, the next step we need to do is we need to publish these changes. So what we need to do first of all is we're gonna just so what we need to do is now push these changes over to OpenShift. There are multiple ways to do that. One that I've chosen here is one that just involves building it locally and then pushing it as kind of like a binary over to OpenShift. So what I do is I just build it first. It takes a few minutes. And then what I can do is I can do something called OC star build, which allows me to say, okay, take this binary and push it over to OpenShift. So if we do that, we can now go to our OpenShift, and we start to see now here that we're starting to, there's a second version being built of the real-time component. That's our component that's going to have the updated. We see it here, how it's now updating it. Okay, so now the version 2 of our application is up. So we just could go back to the IDE. From here, we run our FX application again. And within just a few seconds, we should start seeing delays appearing. So yeah, we start to see our dashboard like as we are feeding kind of a station board that we've kind of compiled about 2-3 hours worth of station board data. We're kind of feeding into the system as delays are happening. We're kind of feeding them from OpenShift via WebSockets over to our JavaFX application, so we can see like delays are happening. So train system in Switzerland is really good, but as you can see, sometimes delays can still happen. So this is the part about the real-time demo that I wanted to show you. So we're going to move on to the analytics part.
And Galder, we do have a question on the demo that I think would be pertinent right now. Why is there a filter in the stream for minimum delay, min delay?
Oh, yes, because when I get the query, so the query is about station board. So this first query gives me, give me a station board where at least one of the entries is delayed. So if I have, the station board has got 10 entries, and one of them is delayed, then I'm going to have, I get as a callback all the station board. So then afterwards, I need to say, of the 10 entries, just extract the one that is really delayed. That's based on the structure of the cache. I could have a structure in a different way so that I didn't have to do the two filters. But at the moment, this is the kind of granularity that I get. Understood?
Yeah, and that's very cool, the concept of having that continuous stream of data and then being able to filter it and modify it and then react to it as it comes in.
Yeah, at the moment it's all only implementing the joining, but you could say if if another result leaves, then I should remove it also from the table, which is not yet implemented, but it could be done easily. Okay, so let me stop this. Let's get back to my presentation. So in the next part, what I want to do is I want to show you a little bit about the analytics part of Infinispan, what you can do with big data analytics here. In Infinispan, we primarily have two ways of analyzing the data. On one side, we've got a Spark Hadoop integration. So what that means is that you can use the very powerful APIs of Hadoop of Spark with an Infinispan backend. So what you do there, you combine the advanced data analytics APIs of Hadoop and Spark with in-memory data grid technology. So all the kind of benefits of data grid. So peer-to-peer communication, no master-slave concepts, etc. Now, the kind of bigger problem of Spark or Hadoop is that they are big stacks that require independent resource management. So they have their own technologies for clustering, using Zookeeper, etc. So they have very powerful APIs, but you should really only use them when you really need them. Alternatively, oops, sorry, I've gone too far. Alternatively, what you can do with Infinispan is you can alternatively use distributed data streams, which allows you to transform and analyze data stored in a data grid. This is essentially an extension to the Java Streams API, so that you can do filter, map calls on Java Streams, but in a distributed fashion. So this is quite cool. The way it works is that one of the key benefit of this is that it allows you for operations to run simultaneously on different nodes at the same time. This is because, as I mentioned earlier, one of the key aspects of Infinispan is that the data is distributed. So for each particular piece, key value pair, there's always one node that is the owner. So what we do is each node is owner for that particular, for certain keys. So when the lambdas or the functions are executed to these nodes, they're executed locally only for the subset for which I'm owner. So it means you get all these nodes working together, like kind of executing these lambdas in simultaneously. And this is a very powerful way of kind of doing distributed processing without the need to bring in Spark or Hadoop. So the next time I'm going to show you is going to use distributed Java streams to answer this question. What is the time of the day, or the hour of the day where you get the biggest ratio of delayed trains in Switzerland? And this is not this is not a trivial thing to answer, as you'll see in the demo. Now, the way this demo is structured, on the front end, we're gonna have like a Jupyter notebook. Jupyter is kind of a very cool technology for writing quick technology for writing kind of data and visualizations and data science related things. And then what I'm going to do from Jupyter, I'm going to take advantage of its diagramming. And then what I'm going to do from there is call into our OpenShift environment. It's going to go to the analytics vertical. This is like another vertical which is going to try to calculate this to get the data to answer this question. The way it works is we've got, again, a data grid of 3 nodes, but in them we're going to have this kind of server task deployed, and that's where we're going to be running our distributed Java streams. So the analytics vertical is going to make a call to one of the nodes, and then the other node is going to be taking, one of the nodes is going to take charge of distributing the streams operations to the other nodes, bringing them back and sending back to the analytics vertical. On the other, what we also have is an injector vertical. This is the one that pushes data into the data grid. Here we're talking about 2.5 million entries, which are 3 weeks worth of data to basically analyze. So let's see this part in action. So what we need to do now is we're going to go to the most important part is the server task. This is kind of like a little bit like a PL SQL kind of thing. where you can just deploy it and run it. Now, what we need to do here is we need to calculate what's the ratio where we get the biggest delayed trains. We need to get a couple of maps in place. We need to get a map saying, okay, between 0 and 1 o'clock, we got maybe 1,000 trains going through. Between 1 and 2, we got maybe 800, etc. And then we need to do the same for delayed trains, but those which are only delayed. So maybe between midnight and 1 o'clock, we got 90. Between 1 o'clock and 2 o'clock, maybe we got 20, etc. So how do we do this with distributed streams? Well, what we need to do, if you look at the cache here we structure in a slightly different way. Here we're basically recording all the little stops that happened in our station points. So what we're interested is about the stops. So what we need to do is we need to collect them grouping by. So we need to say in by. For each stop, what we're going to do is get hour of the day for each of the. Okay, and then we're going to go. So what this is going to give us is going to give us per hour how many stops are how many trains are going through. Now, the thing that is a little bit tricky at the moment is that this collect takes this grouping by returns an object that is not serializable. So a very easy trick that you can do is you can kind of force if something is not serializable. What you can do, you can make the function that creates those collectors serializable. So it's instead of creating the object right here, send the function to create the object to other nodes, and then execute it in its node locally. This is one of the tricks that is part of Java 8, where we can say, you can kind of, if you take an object and pass it to a method, and then you say this method also takes serializable. So this is a supplier that we're passing here. If we say this method takes a supplier that is also serializable, the JVM kind of puts the two together. So it does a little bit of hard work for us without having to do the casting. Now, for the delay part, it's pretty much the same, but with the difference that we need to say only those that are delayed. We're interested here. Now, the cool thing here, we don't have to do any magic here. The predicate that we pass to filter is already kind of forced into being serializable, so it's already ready to be shipped to them. And this is all we have to do. And the final bit I need to do is I need to kind of go to the, I need to rebuild the server task and deploy it. The first thing we need to do is we need to build it, and then to plug it, this is something that is still a bit that we're working through. Underneath, we can just create the jar and push it into a particular place that then the container picks it from there. But there are other ways that we could have done it. We could have done it with volumes or with other ways. But for this, I'm just going to do just a simple copy, and then the server picks it up. Okay, so our server now contains the jar with the task that we want. So I'm just going to go for the last bit of the demo. I'm just going to go into the screen. So here now you see my the Jupyter notebook. Jupyter allows me to kind of go and kind of execute individual calls, so I can execute the imports, get the URL. And finally, in this third line, this is when I kind of do the call. So you see it takes a few seconds. And then once I receive the answer, then what I can do is plot. So we see something that is slightly surprising. We see like the biggest ratio of delayed trains is at 2 o'clock in the morning. And you see as the day progresses and towards the end of the day, you see more trains delayed, which might surprise you. It also surprised me because this is one of the nice side effects of the Swiss train system, is that for the last connections of the day, the connections wait for each other. So that means if you have the entire system, there's one train that is delayed, that has a ripple effect through the entire system for the last connection. So if you're stuck somewhere and then you need to get a train and you need to get your last connection, if that train is delayed, then you can be sure they're going to wait for it. So just for fun, let's have a look at the data so that you see what we're talking about. So even at a rush hour, which maybe would have been what you would expect, you see at 7 o'clock in the morning, you got 99,000 trains running per hour. Like 5 o'clock, you got 113,000. But only 6,000 are delayed, whereas 2 o'clock in the morning, there's 2,300. 321 are delayed. So it's kind of a bigger ratio of delayed trains at that time. That's all I had to show you today. I just hope, going back to the objective, I just wanted to show you a little bit how you can use Infinispan to create an infrastructure that can handle real-time data and do analytics using continuous queries, how we can use them for real-time data processing, and Infinispan distributed Java strings for kind of some basic processing. Thanks a lot to these people who allow me to use their icons here. I think the links are going to be put up. This is the link, the demos that I've shown today. They're in a repo, so you can go and try them. There are instructions and how to do that, how to run them locally, etc. That's all I had to say today.
And we do have a question. At least we have several questions, and more will be coming in. But one that, in particular, I think is important is, could you also discuss again the relationship between Apache Spark and Hadoop and Infinispan? You know, does one include the other, or how do you integrate those different platforms and different technologies?
Essentially, what we do is there is an integration point in Hadoop and Spark, which allows you to where does it consume the data from. So this is an integration point in Spark in Hadoop that we've built, and then we've got these modules that you can kind of use them in your projects, and then they basically see that the data, they feed it or they take it from Infinispan, or they can kind of store it into Infinispan and then kind of consume it again. I think this is particularly interesting if you have already data maybe on Infinispan that then maybe you want to kind of consume from an existing Spark or Hadoop project, or maybe you want to kind of take advantage of kind of the elasticity that Infinispan gives you, as opposed to other kind of working memories for these projects. So that's how it normally works. We've got some blog posts and documentation on how to use them, and yeah, they're very popular as well. And they have very interesting APIs as well for us.
And I do think the intersection where these guys integrate is very interesting. Hadoop, of course, being more disk-based, right? It's not in memory per se. It's moving off Hadoop file system. Spark allowing for its mini, what do they call them? The concept where it has these little mini blocks of streams, right? You know, so it's still in memory, but it's still blocked.
Yeah, but also Hadoop, that's where you switch. So in Hadoop, instead of consuming your data out of ITFS, you can consume it out of Infinispan. So for example, if you already have Infinispan data that you've used for something else, like for keeping some live data, then you can kind of hook it in Hadoop and then process it with the Spark as well. And the APIs are very advanced. I mean, we're not trying to compete head-to-head with the APIs. The APIs are fantastic, very, very good.
So there was an interesting question that came up early on was, have you ever worked for Profitbricks?
No.
maybe there's another Galder out there in the world.
Okay. No.
Is there a, can you give us a little explanation on how to get started? So what you showed us is incredibly advanced, incredibly cool. I love the real-time streaming, the continuous query. I love how you compared it to PLSQL even. And of course, using Vertex to do that, doing that reactive programming model on top. But how would I get started with the basics? You know, just setting up Infinispan, getting started, and then understanding how to apply this continuous query action.
We in our Infinispan.org, we've got an area with little small tutorials which allow you to kind of quickly get started with a particular feature. We've got them for querying, a continuous query, We've got them, for example, if you have a JavaScript application, how can I get started with these tutorials? If you still see my website, I can just, if you go to the community, in the Learn, we've got these tutorials are the best starting point, because they are very focused examples on how you can do querying, remote scripting, for example, to do this kind of server tasks, which you, in my case, I've shown server tasks written in Java, but you can also write them in JavaScript. And then you've got like a lot of ways to get started. That's the first phase. They're very, very small, so very easy to kind of understand and go through them.
All right, well, that is fantastic, and thank you very much for that. And we are out of time for today's session. Thank you guys so much for hanging out with us and spending this 30-minute window with us. The recording will be immediately available as soon as we get disconnected here. But do look forward to other DevNation Live sessions. The next one coming up will be more focused on reactive programming and another deep dive more into that reactive programming world with Vertex. And do look at the actual developersoverhead.com/DevNation Live for other archives, and we're going to be scheduling many more of these things into October and November and other exciting content like you saw today. Galder, thank you so much. Awesome demonstration, great introduction to those concepts. Thank you so much.
Thanks, Per. Thanks, everyone, for attending. And yeah, thank you.
Yeah, absolutely.